Hello everyone, my name is Suparshva Patil and today I will explain the topic of sigmoid and cost function from the subject of machine learning. This topic is very important because it forms the foundation for logistic regression and deep learning models. So, why we need the sigmoid function and cost function? In machine learning, especially in classification problems, we often need probabilities as outputs instead of raw numbers. For example, predicting whether an email is spam or not spam. We need a probability in between 0 and 1. This is where the sigmoid function comes in. It converts any real number into a range between 0 and 1. But just predicting is not enough. We need to measure how far our model is from the actual value. This is done by the cost function. Cost function helps measure model accuracy and guides optimization. Without these two, we cannot train a good model. For example, predicting whether a patient has a disease or not. Let's understand the concepts. First one is a sigmoid function. Sigmoid function is a mathematical function that converts any real number into a value in between 0 and 1. The formula for the sigmoid function is sigma of z is equal to 1 upon 1 plus e to the power minus z. Here, sigma of z is basically a sigmoid function applied on z. This formula takes any real value and maps it to 0 and 1. If the z is large positive, the output is close to 1, and if the z is large negative, output is close to 0. This is very useful in classification because it gives us a probability score. The second one is cost function. Cost function tells us how good or bad our predictions are. For sigmoid-based models like logistic regression, we use binary cross-entropy loss. The formula for the cost function is j of theta is equal to minus 1 by m summation of in bracket y log of y hat plus 1 minus y log of 1 minus y hat bracket complete. Here y is the actual label like 0 and 1 and y hat are the predicted probabilities that are formed by using sigmoid function. This penalizes wrong predictions more heavily. Example, if output is 1 but model predicts 0.1, the cost is very high. This is calculated by using the cost function. For example, logistic regression uses sigmoid for predictions and cost function is used to minimize the errors. Now we see how do they work together. First, we calculate z as a linear combination. The formula for the z is equal to w1 x1 plus w2 x2 till wn xn plus b. Here w1, w2 and wn are basically the weights and x1, x2 and xn are input variables and b is the bias. Then we apply sigmoid function on it. The sigmoid function is 1 upon 1 plus e to the power minus a. This sigmoid function gives us a probability output. Then we compute cost function using actual labels and predicted probabilities. Finally, we use gradient descent to minimize the cost by adjusting weights. For example, training a binary classifier with a sigmoid activation and cross entropy loss. The workflow for the sigmoid and cost functions are: First, we take inputs, we combine them, and then we check the probability by using the sigmoid function. Then we compute the error by using cost function, and last we update the weights by using the gradient descent. Let's see the challenges and limitations. Sigmoid suffers from the vanishing gradient problem. When values are very large or very small, gradient becomes close to zero. In deep neural networks, this slows down the training. That's why we often use the ReLU activation function in neural networks. Also, the cost function must match with the activation function. Using the wrong combination, it will give wrong results. For example, using sigmoid in deep layers can lead to poor convergence. To summarize, sigmoid function helps convert values to the probabilities, and cost function measures how accurate the model is and helps improve it through optimization. Both are essential for logistic regression and some neural networks, but not ideal for very deep models. Thank you.